Okay, now we are in the last part of chapter 10, which is we are going to find a rate of change. So what is a rate of change? Let's say we have the question said a rate of change of y. So we are going to write that as dy over dt. Okay, it must always over time, over dt, dy over dt. Okay, so how are we going to solve a rate of change question? So the most important formula is this formula. I think you recognize this formula. This is a chain rule, okay? Or we can use this part here. This one bergantung. Let's say you want with respect to h, with respect to r, radius, height, this one depends what the question asks, okay? And one more thing, for rate of change, this is very important. So if the question said that the rate is decreases, okay, rate decreases or reduces or leaks or escapes, okay, all the negative things, you have to know that your rate, let's say I put it as dx over dt, your rate must be negative. Okay, so let's say I put it as dx over dt, your dx over dt must equals to negative. Okay, so let's just go to example 12. Here the question said gas is escaping from a spherical balloon at the rate of 2 meter cube per minute. So we have a spherical balloon. Okay, tak perlu pun lukis, sajalah saya nak lukis, memeriahkan soalan ni. So we have a spherical balloon. The keyword here is gas is escaping. Okay, from a spherical balloon, gas is escaping. So we are talking about a volume. Okay, so here we have at the rate of 2 meter cube per minute. So therefore, we will have dv over dt is equals to negative 2 because we are talking about escapes. Okay, so must put negative because escapes here. Okay. So if you're not sure what are you looking at, you can always look at the unit here. Here is meter cube. Meter cube means volume, minutes mean time. So we are talking about dv over dt. Okay, so now the question said how fast is the surface area shrinking when the radius is 12 meter? Okay, how fast is the surface area? So we are talking about surface area. How fast? Okay, when we said about fast here, we are still talking about rate. So what are you going to find? We have to find dA over dt. Okay, this is what are we going to find when the radius is 12 meter, when r equals to 12 meter. Okay, so that is all what we have. So first, talk about spherical balloon. We should have the volume, the formula for volume, the sphere. Okay, volume for spherical, so that would be 4 over 3 pi r cube. Okay, same just like before, we just differentiate this one here. So differentiate v, we should get dv over dr. Okay, so because we have r here, you can always change into a single variable. So here we will have 4 over 3 multiplied by 3, we will have 4 pi r square. Okay, now we are going to use our chain rule. Okay, from here, dv over dt. So that will be dv over dt equals to dv over something multiply something by over dt. Okay, from this part here. So what is something here? Obviously that will be dr because we already have dv over dr. So this will be dr, this will be dr. Okay, as we look at this chain rule here, you can see that dv over dt we already have. Okay, dv over dt we already have from the question here. Okay, so this one we have. dv over dr we also have from this part, from this formula, from the formula we have dv over dr. So we want to find dr over dt. Did we want to find dr over dt? No, the question asked for dA over dt. So okay, just find your dr over dt. So here dv over dt given in the question as negative 2. dv over dr we have 4 pi r square multiplied by dr over dt. Okay, so now we can simplify. Our dr over dt is equals to negative 2 over 4 is negative 1 over 2 pi r square. Okay, we don't want to find dr over dt, we want to find dA over dt. So therefore, we can use this to help us find dA over dt. So here we have dA over dt. Obviously, you have to write your formula for the area. So area for a sphere, that will be 4 pi r square. So now we can differentiate this with respect to r. dA over dr, we are going to get 8 pi r. Okay, now once again, we can write our chain rule. dA over dt is equals to dA over something. So dr multiplied by dr over dt. So let's check again. dA over dt is what we want to find. So this is what we want to find. dA over dr we have here. So this one we have. dr over dt, this one is from this part. That's why we have to use the volume. Okay, so that we can help us to find dr over dt. So now we just substitute. Our dA over dr is 8 pi r. Our dr over dt is negative 1 over 2 pi r square. So simplify everything, you should get negative 4 over r. So the question said find dA over dt when r equals to 12 meter. So just substitute. When r equals to 12, dA over dt is equals to negative 4 over 12, negative 1 over 3. A is meter square, time is minute. Okay, so that's gonna be your answer. Check it back. The question said, how fast is the surface area shrinking? Okay, shrinking. That means your rate must be negative. Do you have your negative here? Yes. Okay, so the answer is correct. Alright, so now moving on to example 13 here. So the question said, water is running out of a conical funnel at the rate of 1 centimeter cube per second. Okay, let's draw a conical funnel. So we have a cone here. Ini bukan cone. Okay. Okay, so we have a cone here. Water is running out. That means this one here is talking about the volume. Okay. Volume running out. That means keluar. Okay, so your rate must be negative. So we already have dV over dt equals to negative 1. Okay, so that is what given for us from the first sentence. If the radius of the base of the funnel is 4 centimeter, so the base here is 4 centimeter, and the height is 8 centimeter. Height of the funnel is 8 centimeter. Find the rate at which the water level, so talk about water level here, is actually your H. Okay, is dropping when it is 2 centimeter from the top. Let's say your water is here, 2 centimeter from the top, 2 centimeter from the top. So let's say this is 2 centimeter. That means the height of the water is actually, the height of the conical funnel is 8 centimeter. So 2 centimeter from the top, that means the height of the water is 6 centimeter. So remember, the question said find the rate at which the water level. We want to find dH over dt when it is 2 centimeter from the top. So the height of the water is actually when H is equals to 6 centimeter. So make sure to read the question carefully, okay, because the question said 2 centimeter from the top. Okay, so that is what we have, everything that we have here. So now we are talking about volume. So we have dV over dt here. So let's write the volume for the cone here is 1 over 3 pi r square h. Okay, so back to optimization problem. If you want to differentiate this, it should be in single variable. So here we have r and we have h. So how are we going to use this? How are we going to differentiate this? Back to the picture that we draw here, when we said about conical, a cone or a sphere, if your height is here, okay, the radius is different. Okay, the radius varies with the height. Okay, if at 2 centimeter, let's say at 2 centimeter, your radius is small. Okay, if at 8 centimeter, your radius is bigger. So therefore here, for conical, for a cone, you can always write a ratio. So that means a ratio for h to r. Okay, as you seen from here, we have our h is 8, our r is 4. Okay, so do you want to make your r as a subject or h as a subject? Depends on the question here. The question said about dh over dt. You want to find the rate at which the water level. So this one must be in terms of h. So therefore we make r as our subject. So r is equals to 1 over 2h. So we are going to substitute this into here. So we will have equals to 1 over 3 pi r square. So r is 1 over 2h. Okay, so now simplify. 1 over 2 square, we will get 1 over 4. Multiply by 1 over 3, we will get 1 over 12 pi h cube. Okay, so that is our volume. Okay, so once again, for cone or a sphere, whenever the radius varies with the height, you can always write this ratio here. Okay, write this ratio. Okay, to help us make this as a single variable. So depends, you want to make h or r, depends on the question here. So now we can differentiate this, differentiate v with respect to h. So you are going to get pi h square over 4. Okay, 1 over 12 multiplied by 3, we get 1 over 4. So now we already have everything that we want. Now we are going to write our chain rule. dv over dt equals to dv over what multiplied by what over dt. So what are we going to apply here? dr or dh? Obviously dh, because the question asked to find dh over dt. So here is dh, here is dh. So do you have your dv over dt? Yes, from the question. Do you have your dv over dh? Yes, from the formula. So we want to find dh over dt. So dv over dt is -1. dv over dh is pi h square over 4. And this is what we want to find, dh over dt. So here, simplify, we will get -4 over pi h square. Okay, so remember the question said when h is 6 centimeter, or the question is actually said 2 centimeter from the top. So 2 centimeter from the top, that means the water level is at 6 centimeter. So when h is equals to 6, dh over dt equals to -4 over pi 6 square. So here you will get the answer, -1 over 9 pi centimeter per second. Okay, so that is how we want to find dh over dt. So actually rate of change is very easy. Just go back to our chain rule here. Okay, let's try one more question here. We have given 1 over u plus 1 over v is equals to 1 over f with f as a constant. Okay, if f is equals to 10, the question already said that f is a constant. So we just substitute 1 over u plus 1 over v equals to 1 over 10. Okay, and u decreases with the rate 2 meter per second. So the question gives to us u decreases with the rate. That means du over dt equals to -2. So the question asks to find the rate of change of v. So you have to make your v as a subject. Okay, so make sure kamu tak substitutekan 40 ni dekat dalam ni sebab bukan constant. We are going to differentiate v with respect to u. So now we make it v as our subject. 1 over v is equals to 1 over 10 minus 1 over u. And then we are going to have kita samakan denominator lah, senang. u minus 10 over 10u. So v is equals to 10u over u minus 10. Okay, so you know that you have to differentiate v with respect to u, so we are going to use quotient rule here. So your u equals to, okay, this is what is given to us. U is equals to 10u, differentiate u with respect to u, kita akan dapat 10, v equals to u minus 10, then therefore your v prime is equals to 1. So to find dv over dt, just use the formula for quotient rule. U minus 10 multiplied by 10 minus 10u over v square, u minus 10 squared. Okay, simplify, you are going to get negative 100 over u minus 10 square. Okay, so now we can apply our chain rule. So you will have dv over dt equals to dv over du multiplied by du over dt. Okay, so this one we have here from the formula, from the first derivative. This one dv over du we already have from the so dv over dt we already have, we want to find dv over dt. Okay, sorry. So this one you want to find, dv over du. Sorry, this one should be dv over du. Okay, differentiate v with respect to u. Okay, this one we already have from the formula, this one we already have from the question. So now just substitute everything. We should have negative 100 over u minus 10 square multiplied by negative 2. So therefore you should have dv over dt equals to negative 200, positive 200 over u minus 10 squared. So now you can substitute your u when u equals to 40. When u equals to 40, your dv over dt is equals to 200 over 40 minus 10 square. Therefore the answer here is 2 over 9 centimeter per second. Okay, so a little bit different from what we have already done from the previous question, but still the same. We are going to use we use chain rule as the main part in this question. Okay, now let's do the last question for rate of change and for chapter 10 and for this semester. Last part here. Okay, a 10-meter ladder rests against a vertical wall. If the bottom of the ladder is sliding away, talk about sliding away. So the bottom of the ladder here is x. Therefore, we should have dx over dt. From the base at the rate of 3 over 4. So that should be negative, sliding away 3 over 4. Okay, positive 3 over 4. How fast is the top of the ladder? So that means we want to find dy over dt. Okay, y. How did I know that? So this is the top of the ladder, y. So you want to find how fast. Whenever we talk about fast, that means we want to find the rate of change. So we want to find dy over dt. Okay, so now we have just a triangle here. Okay, just a triangle. We have a ladder here, we have the bottom, we have the top. So from this here, you know that what formula that we have to use. Every time we look at a triangle, you know that you have to apply a Pythagoras theorem. So that will be x squared plus y squared equals to 10 squared. Okay, so now as I said before, from this part here, we can differentiate v with respect to u. Actually, you can always differentiate from here. How are we going to differentiate without making v as a subject? Okay, like this part here. How are we going to differentiate without making x as a subject or y as a subject? You are going to apply implicit differentiation. Okay, implicit differentiation. So let's differentiate everything with respect to x. So differentiate x squared with respect to x, you are going to get 2x. Differentiate y squared with respect to x, you are going to get 2y, apa yang kita kena letak kat belakang? dy over dx. So differentiate tan square will get you 0. So simplify, your dy over dx is equals to negative x over y. So that is our first derivative. Okay, now back to our chain rule. So we will have dy over dt equals to dy over dx multiplied by dx over dt. dy over dt we want to find. Okay, this is we want to find. dy over dx we already have from the formula. We have dx over dt we have from the question. Okay, now we can find our dy over dt. So negative x over y multiplied by 3 over 4. So the answer here is negative 3x over 4. Okay, but remember the question said when the bottom of the ladder is 6 meter from the base. That means your x is equals to 6. Okay, we already have the value for 6. So how are we going to find the value of y? Just substitute into this. So when x equals to 6, you will have 6 square plus y square equals to 100. So you should get y equals to positive 8. So just substitute. When x equals to 6 and y equals to x, we will have our dy over dt equals to negative 3 multiplied by 6 over 4 multiplied by 8. And our final answer will be negative 9 over 16 meter per second. Okay, so that is how we do rate of change. Basically, just apply your chain rule here. So for exercise, this one here you can do it by yourself. This one is the answer, and the last exit ticket for this semester is exit ticket 30. Okay, so this is the question, panjang sikit. You have two things that you have to find here: rate of change of the water level and the rate of change of the radius. Okay, that is all, guys. Thank you so much for everything. Thank you for your commitment. I'll see you guys when I see you guys. Thank you very much.